All right, I think we're going now. Hey everyone. Hope everyone's breaks went well. Definitely a much needed break for me. I'm excited for this next semester, and over the break, I went through and wrote down a little bit of the knowledge that I've acquired over these last few years on the ECU and stuff that I've learned. And I hope that these instructional videos will give everyone at least a basic idea of what the ECU is, how it works, and a top level view of the architecture of both C-car and E-car's ECU. So it's pretty clear I didn't do much in terms of knowledge transfer last semester. Hopefully these videos will change that. So this year, like, what is my job? I'll be managing at least the high level controls for both E-car and C-car, and also managing the data acquisition systems. Um, as of right now, C-car is going to be maintaining the AIM Evo 5 system. E-car may run the Vector or switch to the Evo. I'm still unsure about that, but regardless of whatever it is, I'm going to be pretty familiar with both those systems. E-car and C-car do use the same ECU, so most of the stuff that I talk about in these, at least basic videos, applies to both cars. So what is the ECU? What do I ECU? What do I keep talking about? What is it? So the ECU we use is called the Mototune PCM 112. It's a development ECU from New Eagle or Woodward. They've changed names over the past few years, so New Eagle, Woodward, whatever. It's an ECU intended for companies to quickly prototype control strategies that will eventually be rolled out into production vehicles. So a company buys a developmental ECU from these guys and tests a bunch of their control strategies. Once they finalize the strategy that works for them, they can go to another company, develop like a production ECU that they run in all their cars. So since we don't release a production vehicle, I guess, we stay in the prototype cycle. So most of the stuff we do stays in the development cycle. That's why we purchase the development ECU. And that's why theoretically we can iterate through strategies and calibrations pretty quickly if we understand the process to do it. And I think I've made steps in to learn that process, so I'm hoping I can share that with you. We've been running this ECU for a very long time, and as much as I continue to berate it, sometimes you've heard me say, "Oh, I hate this ECU." It's pretty much faultless. Only fault being lack of knowledge transfer. So hopefully that I can change that. We can actually develop some cool stuff this year, and I'm excited about that. There are two separate concepts I want to make sure people understand when talking about RECU. At least at the top level, there is the calibration and the SRZ, or the source code. So whenever I make a change to the code, we build a new SRZ. So the code is like actually created in MATLAB, and every time I build that file, it creates an SRZ, which is a program file. So let's say it's on the bottom level. Every time I make a change to the tune, I adjust some parameters. That's on the calibration. So the calibration sits on top of the SRZ. It's very important to understand. That means that if we want to adjust fuel, spark, air, or whatever other e-car wants, we don't have to build the file program flash the ECU every time. We can just edit the calibration. So those are a distinction I wanted to make. I'll run through some screenshots of, I'll actually pull up Mototune and MATLAB in a bit so we can correlate some of the stuff I'm talking about. So the Motohawk compiler. So the Motohawk compiler is part of the ECU system that lets us code the ECU. So it uses Simulink to create the C code that is then flashed onto the ECU as an SRZ. Because line-by-line code would be kind of confusing, and the control strategies with arrows and blocks make a lot more sense, Motohawk uses the Simulink code, which is, I'll show you, which is block-based arrows. Cool to look at. Sometimes it can be very difficult. And I quite honestly don't understand a lot of the very complex strategies. So we'll step through that. So first, fuck out of here, Windows Update. First, I will go over Mototune and the process we use to connect to the car every time we need to monitor values or change calibration settings. So I will switch over to this. Okay, you guys see the screen now. So I will open a Mototune. So what's important to know is that Mototune requires a hardware license. So I have the dongle with me right now. It's plugged in. And actually, it's interesting. So it's not opening. Just kidding, it opens. Sometimes it takes a while. These tips are actually sometimes helpful. I never looked at it before, but I'll look at it now. So when we're connecting to the car in the shop, there's 4 pretty much basic steps that go on. The onboard battery or off-board PSU power supply is connected. We turn the e-stop on, and we put the emergency switch on, and then we pull e-stop out. The CAN 3 terminates in the steering wheel, so if there's some communication issues, try to put the steering wheel back in and out again until it flashes up. Sometimes it fixes things. So Now I have Mototune open here. As you can see in the top left, it says Mark Lemonchik. I think that's how you say his name. This is the name of the license we have. If I pull out the key, it'll say unlicensed and it won't let you do anything. So there's the two main parts here are the display and the calibration. I will talk more about what those two things are. But to open a file or calibration, I will do Control O. So Control O opens all the calibrations. So for example, right now, I'm just going to use the most recent one. So click Open here. So because we're not connected to the ECU, I don't have an ECU with me in Ann Arbor, I'll have to go offline. So I will just say yes, offline. So right here, there are a bunch of these folders that each correspond to a part in the SRZ, which is in MATLAB. So I'll step through some of the stuff here in a bit, but essentially your injectors, your actuators, your brake lights, so I can manually toggle stuff, all that goes here. So all of the maps, fuel tables, spark tables, all of that goes in this file here. But the file that's actually interesting to look at is the displays file, so we'll do Alt-O for that, or we can do right-click the display, and we can go to 219 torque, which is the one that's been using for the last 3 years, so I'm going to continue using it. So once this opens up, so since the ECU is not connected, obviously all these are not available, but when the car is connected through CAN, we'll be able to see all these sensors. So oil pressure will be reading a certain range, coolant temperature, battery voltage, whatever sensor we have plugged into the ECU will be read here. What's important to notice that if you want to add something to the display, let's say, so these are a list of all our valid display stuff. And I can't see because the car's not connected, but usually you'll be able to drag. Can I drag this? So I can drag stuff to this Excel spreadsheet. Project ID is something I don't really care about, but when you're connected to the car, you'll see, like, for example, brake light on or off, and you can drag that in and you can create it in a file. These green, blue, yellow, happy colors here are blocks that change whatever the certain range is. So we've specified in the code, okay, if air temperatures are 355,000 degrees Celsius, it'll turn red. So it gives you kind of a quick understanding of what the car is at the time. Again, this is C-Cars code, so E-Cars looks a little bit different, but the glorified Excel spreadsheet stays the same. Another thing to notice here is whenever we have things called enable, disable, or like a drop-down menu, like so for example here, I can click E for enable, D for disable. I can toggle through these. This appears as a probe in the code, and when I step through the MATLAB code later, I'll show you where the probe exists and how you can change those two settings. So right here, this is how we would enable the pseudo RPM if we want to do our throttle check. So a bunch of the dependencies need to be checked. So we have pseudo RPM for that. Let's see what else. When you drag a value from the display, it'll be on 100 millisecond refresh rate, but to reset that as fast, we right click it, we properties, and we click set fast. So this basically is how quickly the values update. And by default, it's 100 milliseconds, and we can lower it down, obviously. So the calibration tables, I will open up one here. So, where am I going? Sorry, I'm trying to find a table that actually could be pretty simple to understand. So, right here we have our shift shaft LDX array. I'll talk more about LDX and tables right after this, but essentially whenever the ECU wants to look up something, we have our raw values here. So these are our raw ADC values. ADC stands for analog to digital converter. So this is I believe 10-bit, so this is 1023. This feeds in directly to the shift shaft position input on the ECU. The ECU looks at this and then has a table that interpolates each of those values. So each of these are a degree measurement, and this is how much the shaft moves, for example. So that's the way the ECU does. It's because it's not a fully modeled system. Everything uses lookup tables, and this is one of the ways it works. I can also look at throttle. So throttle is also pretty simple to understand. We can look at APP. So APP stands for Accelerator Pedal Position Sensor, or APPS. We have the LDX array here and the table. So right now, as you can see here, we have our throttle percentage at the bottom here. So it goes from 10% to 80%. We roughly idle around 9% throttle, but the throttle configuration table is in a different set. So when we're cranking and we're idling, we're in a different table, and as soon as we apply pedal position, we go to this table. So this table maps your throttle position to your pedal position. So right here you have your raw ADC values. You have just the direct value going straight to the ECU, and this is attributed to the table here. So for example, there's two APP sensors here. On the left side, there's APP1, APP2. That's used for arbitration in case one of the sensors is screwed up. Then it'll be like, oh, throw a fault, turn off the car, stuff like that. It's pretty safe to have, and the rules mandate we have that arbitration. So right here, as you can see, C-car is right now limited to 80% throttle. So if I wanted to be adventurous and get, okay, 100% throttle, I would make that 100, and then I would use this magic button here to interpolate all the values in between, so it's nice and smooth. There's some scenarios where we want a larger tip in the throttle at the beginning, low at the end, but all of that can be tuned. But basically for now, if we want to set our throttle percentage for C-car, we just adjust this final value here. So I'll go back to 80. Click here, shift, and then I'll click the little magic button. Cool. So that's a very basic set to Mototune and the stuff that goes on here. I'll open up the display again. I don't know why the display closed on me. The online button is right here, this plug icon, or you could right click and go online when the ECU goes online. So obviously not connected right now, so do anything, but we can still continue online. Any other questions? Feel free to Slack me. This is just a basic overview of Mototune. This is what I sit at every time of the track day. I'm looking at values, checking stuff. I'm in this application right here. So that'll be it. Thanks for watching.